Welcome to Cpp.chat, an analysis of what's going on in the world of C++, chatting with guests from the community. But before we start looking for this week's bugs, John has some disclaiming to do.
Thank you, Phil. In this age of digital recording, audio, video, and session file usage and storage have become major issues for studios and clients. Due to the unreliable nature of this digital world, Cpp.chat Studios, LLC will not guarantee the safe use or storage of digital audio files. We strive to do our best with file manipulation and storage, but there are many things out of our control. For example, there are often bugs in operating systems and attendant software, hardware components that suddenly become defective in hard drive power supplies and IC boards, glitches in the operation of complex computer functions, etc., that cause from time to time losses in data. Although such losses are infrequent, Cpp.chat Studios, LLC accepts no liability for the usage or storage of any data or files. So, welcome everyone. Welcome Yuri. We have a guest today from PVS Studios, and we're going to talk about that. But I think first we're going to do some news, right, Phil?
Yeah, I think last time we said on the subject of conferences, we usually do a conference roundup. We said the news was everything is cancelled, which to the first approximation that was true. Interestingly, this week there is a bit more movement going on. So I'll let you talk about CPPCon in a moment, John, but also Meeting C++ just announced that their call for speakers is open. They are planning a physical event, but obviously even by November, we're still not sure what the situation is going to be. So Jens is prepared for moving that either partially or maybe even fully online as the situation becomes clearer. So he's full steam ahead preparing for that at the moment. ACC Belfast, also in the autumn, the fall, has been cancelled now. And C++ Russia, they'd moved their physical event from April to June, I think, originally. They've now announced that the June event is going to be online. So I think that might be the first major C++ conference to go fully online, so it'll be interesting to see how that works out. And then, John, you've got CPP.
Right. So CPPCon, we've opened our call for submissions. And one of the things that we announced about that is that we have changed our format, and we're going from having 60-minute standard sessions to 75-minute. And by the way, our plenaries have always been 90-minute. But what we're doing is we're going from, we used to have 5 sessions a day, which included a 90-minute plenary every day and 4 hour-long sessions, and we're now going to have only 3 sessions, and they're going to be 75-minute sessions. So it's pretty significant change, and part of the reason is that a lot of speakers ask for longer time. I know, Phil, you've spoken at a number of different conferences. I assume you've done hour-long talks. I assume you've done 90-minute talks. I assume you've done 75-minute talks. What are your thoughts on those? I think you're muted, Phil.
Still muted.
We'll assume Phil said something brilliant about talk lengths, and we'll let him worry about his audio systems. Anyway, the point is we had gotten some feedback from speakers, but I think what was probably more compelling was that we've got a lot of feedback from attendees in our surveys, and the single biggest negative factor that attendees had identified, and I don't want to make it sound like there were lots of negatives. Most attendees surveys are great. They're fun to read. But one of the things that was the most thing to come up was speakers talking too fast. Now, part of that's just nervousness. We're not professional presenters, we're professional coders. But speaking too fast and trying to present too much material. And I understand this. I'm completely in touch with this. You know, when I do training, I get to talk for multiple days. And then when I try to say something in an hour, it turns out, wow, that's a little more stressful than you think. So you talk really fast, and you can get all these points covered, and then you feel good at the end if you've covered everything. But the problem is, yes, you got to cover everything, but the audience didn't follow what you were talking about because you were talking too fast. And so that's what we're trying to address. So by, I think, going from 60 minutes to 75 minutes, you know, one of the things that I've had explained to me about people who have spoken at C++ Now, which is a 90-minute for every session, and they come to CPPCon, and they feel like you spend the first 45 minutes setting up the problem, getting people to understand what you're talking about and get the context. and then just about the time you're ready to get into the real meat and you get into the really good stuff, that's about the time you have to say, okay, well, we probably ought to leave some time for questions. And so that's the challenge. It turns out that 60 minutes is not really the sweet spot. So we're hoping that 75 minutes works better. So that's what we've done. That's the big news. The other news, of course, is just that yes, the call for submissions is open. Are you with us again, Phil? Doesn't look like he
No.
is. Okay. All right.
Actually, that time I was muted.
Oh, yeah. Okay.
The cable from my microphone fell out previously. And then when I
Did I
reconnected
tell
it,
you
I
the
decided to
disclaimer?
use it as my output device.
This is one of those complicated components that can fail mysteriously at any time. And so,
Oh yeah, happens all the time. Oh,
So,
by the way,
yeah.
about those, I just wanted to add my 2 cents. I've seen a couple of people who were given like an hour timeline for that talk, and they finished like in half an hour, and but it was like a machine gun speaking.
yeah.
Quickly just dash through the slides, and it wasn't pretty.
Yes. Well, the more you practice, the more relaxed you are doing it, and the more relaxed you are, the better able you'll focus on the communication instead of the actual getting through it of it. But I did ask you the question, Phil, and I was kind of curious because I couldn't hear what you were saying, but it looked like you were saying something terribly interesting.
Oh, I was. It was really interesting. I got through it really quickly, and now I've completely forgotten what it was. No, I was going to say that, I've done, I don't think I've done 75-minute talks. I've done plenty of 60s and 90s, and often done the same talk of the same core material in multiple formats, and generally not really had to adjust the material so much, just spend less time so going in depth and taking questions. They do say that a 90-minute talk is really a 60-minute talk with lots of time for audience participation.
Ideally, yes.
Yeah.
Right. So I actually would have liked to have gone to 90 minutes, but I think that 75 is a good. It is a good. And of course, for those who are terrified of the idea of filling 75 minutes, we still are offering half sessions. That we didn't actually change the time for the half sessions. One of the problems we've had with half sessions is that doing 2 half hours in an hour is a really tough transition because you have to make certain that the first speaker doesn't go over by any time at all so that they can immediately cut over to the second speaker. That's really hard to do. So what we're going to do for half sessions is we're just going to have a little bit more. We're still going to target 30 minutes for both and just have a little bit more time to make the transition between. And I think that's better than trying to say, well, we're going to make them, give everybody another 7.5 minutes or something. I don't think that's going to work too well. So that's the idea. Anyway, do we have other news we want to talk about, or do we want to start talking to Yuri?
I think we can get started.
All right. So Yuri works for PVS Studios, and the product is a static analyzer. And I'm fascinated by static analyzers. And you want to just give us the high level? I suspect most people listening probably know what a static analyzer is, but just what is the idea?
Okay, so the basic idea. Everyone knows what code review is, right? So you sit at some guy's desk and you look through code and try to figure out what's happening there, maybe fix something. Static analysis is what I like to compare it to code review. It's just automatic. Of course, it has limitations. Basically, it's a way to take your source code and feed it to the to basically a compiler's front end, which will parse it, and then it will go through the entire code. But instead of generating code like the binary module, like a compiler would do, a static analyzer will run some diagnostics on this code. And in the end, you get an output of warnings which tell you, okay, in this fragment of code, this and that happens, and that's bad, really bad. or maybe not really bad, but yeah. The basic idea is that the machine looks through your code and tells you if it smells something.
Right. So compared to a human doing a review, the human can give you good ideas about variable names, can give you good ideas about comments. And if you have a dynamic checker, then it can look at values that are changing over time. But the value of the static analyzer is it can immediately calculate all the potential paths. And so what a dynamic checker may never find a leak because the particular tests you give it may not exercise that. Whereas the static analyzer can see there is a potential path that will leak.
Yes, exactly.
And that's something that a human isn't necessarily good at, although some of them might be better than others. And a dynamic leak checker isn't going to find unless you go through the path that exercises.
Yeah, for a dynamic analyzer, well, they are still good, and you should use them.
Yes, yes.
But you need to prepare data for it in a specific way so that your buggy code gets executed at least once. And for dynamic checkers, their weakness is that, yeah, like you said, if it doesn't go there, it didn't happen.
Right.
So yeah, and static analysis, well, for code review, it's kind of an addition because a human can tell you not only about comments or variable names, but about algorithms, for example. So you solved some problem like this, but it would be more efficient to do like a different way of coding it. A
Right.
static analyzer cannot tell you that.
It's not really focused on efficiency.
Well, it's kind of focused on efficiency, but it's a low-level efficiency. It's like, okay, there's an unnecessary copy here,
I see.
or yeah, so
I see.
Stuff like that.
You're doing things that are never used. It can see that.
Yeah. And what else? People are really interesting creatures because they have short attention span sometimes. I'm guilty of that too. And when you're looking through some code, especially if it's like monotonous, similar blocks and something, you just burn out really quickly and you stop seeing stuff. And this thing, static analysis, it just doesn't care.
It doesn't get bored and it doesn't get tired.
Yeah, it will go through your check of 25 variables in one if block, and it won't even. I don't know. It won't even cough.
So
how does the joke go? It's got a code review for like a 1,000-line function, and everyone says, "Yeah, that's fine," but you give them one line and they'll spend 2 days.
that's right.
I've seen once a code review for templates from a guy who's not really into templates. So he goes up, looks at the code. Okay, it's fine. It's good. Oh, templates. I'm sure it's fine. I'll just go. Yeah, so that was funny.
So the kinds of things that it's likely to spot, certainly it can spot if there's a path where you use something that was never initialized. It can find paths where things are never properly freed or released. It can find situations where you are doing something and then not doing anything with that thing.
Yes, we have this for loops more specifically. Is when sometimes you can have a loop where the condition of that loop doesn't do anything. So you either get an infinite loop or it just executes once. We have a rule like that. It can do that, like it can look at your code and find something you did something with and you don't use it anywhere else, so you didn't have to do that. But sometimes it's kind of limited because it's not easy to understand for a static analyzer uh, if you had to do it or not, because sometimes you just don't know what happens in a specific function. Let's say you did something, you calculated some value and you put it into a function as a parameter, but the function's body is somewhere in a different translation unit or in a static library or something like that.
Right.
And the analyzer doesn't see it, so it won't be able to tell you anything about it. Usually we just ignore that. So if you don't understand what's happening, you don't have enough information. You just shut up about that and don't bother the user.
So does the static analyzer, well, I guess different ones could work differently, but the one you're working on, does it follow the same rules of inlining from the point of view of the compiler? In other words, you're not trying to look at multiple translation units and dive into this function you're calling and saying, well, we've looked at the function and you're passing a parameter that's not used, or
yeah, we don't have multiple translation units. We check them one by one. So
just like the compiler builds them.
Parallel. Yeah, just like the compiler. And we don't have anything like a linker. We wanted at some point to do an intermodular analysis, but we decided it would be too heavy. It would be
Pretty ambitious.
a performance hit. Well, even if we managed to do that, the analysis would start taking like ages. It would be slow. It would be really.
Because it doesn't scale well. The more modules you have,
doesn't.
Yeah.
Surprisingly, right?
Yeah. Well, talking about performance, how does the analyzer compare to a compiler?
It's about the same. It can take about the same time as a build, minus the linking, of course. So you don't have to do linking, so it may be faster.
Okay, so so tell me what we've been talking about a kind of theoretical point of view. What in practice do people find? What kind of bugs? I suppose it varies somewhat between projects, but I'm sure you see, you get reports. The first time I ran it, I found all of this. What is that? What's the most common bug that it actually does find?
Well, maybe it will sound surprising, but I hope not. It's copy paste. It's when, for example, you initialize a bunch of variables and you copy paste your lines of code. Of course, who doesn't do it?
Yes.
And you forget to change the variable name somewhere.
So somehow you're initializing the same variable twice, or you're initializing two different variables to the same thing, and it's not because of any fancy logic or anything like that. It's just I copied all this code and I went back and I made all the little changes, except I missed the little change in a few places.
Yeah. Today I've had a review with my colleague, and we found a bug. My computer got decided to enable a screensaver for some reason. Okay, so we found a bug that wasn't noticeable enough to be found by tests, and we found it by looking at the code. He forgot to change the variable name in two copy-pasted method calls, and each of them had like 5 parameters, so the lines were really fat. The calls, I mean, the code for calls. Yes, and we found that one variable wasn't changed, so it was working incorrectly.
But that is something. But you found that by code review, not by static analysis.
Yeah, but
it was a cut and paste situation still.
It was. Right. We didn't run it before we looked at the code. So
how? And I'll tell you the story. And I worked for a big company that's actually famous for having lots of money. and we bought this very, very expensive static analyzer. And I don't think that the people on the team were, I mean, this was a management decision. They went out and bought a static analyzer. Hey, guess what? You're getting a static analyzer. And the people on the team were like, oh, okay. I didn't know I had lots of extra time to investigate and other stuff. But okay, if you say so, I guess I do. But nobody really knew how to use it. I assume it was properly installed. I don't know, but it wasn't part of our regular routine. It wasn't run regularly. I do know that when it got put in, I was really curious. It's like, oh, what is it? What is it? What is the result? What is it telling us? There must be, you know, I'm gonna close a whole bunch of bugs, and there was some interesting stuff, and I would say probably not a surprise. The things that were truly bugs tended to be small. They tended to be like, oh yeah, I guess there is a situation where this could happen. But of course, if it was happening a lot, we would have found that already. You know, I mean, it's not like we never tested, right? So I really appreciated it, because when that does happen, it's going to be some user that's lost data. And, you know, so I'm always happy to get rid of bugs, but there were a lot of false positives too. And I subsequently read more about static analysis and found out that false positives are kind of the bane of the static analysis existence. So is that what you found? Is that what your experience is?
Yes, they are a huge deal. If you're not careful, you have to be careful with your diagnostic rules, how you implement them. And we constantly fight false positives in our analyzer. And sometimes we find them ourselves in tests. Sometimes people report them, and then we modify our tweak our rules a little bit so that they don't happen.
So what's the problem with the false positives? What's the issue?
Because they, if there are many of them, your log will look like it's flooded with garbage. And yeah, I know that this problem exists in some projects where people just don't want to check them because there are too many false errors.
In other words, if I told you, hey, I found 2 really good bugs in your code, and here's a report of 100 bugs, so 98% of them are a waste of your time, but there's 2 real bugs in there. I mean, it's still worth it. It doesn't feel like it's worth it. It feels like a waste of time. You're going to do the first 30 and you're not going to find anything at all, and you're going to say, this is just a waste of my time. Whereas, no, there's real bugs in there too. They're just hard to find.
Yeah, that's why we try to avoid them at all costs, as fast as we can. I mean, fix them. And we also do stuff like, we have 3 levels of certainty for warnings. Level 1 is where we are sure, okay, that's not a false positive. Well, there is a chance it will be a false positive, but the chance is small. Level 2 is basically, okay, here are warnings, look at them, there might be false positives here. And level 3 is go there only if you want, because the chance of garbage is high.
I see.
Yeah, some diagnostics just make more noise than others.
So give us an example. I mean, what is the kind of diagnostic, and then why is it that it might actually be okay? Why might you're thinking, oh, this doesn't look right. Then it turns out, well, no, it might be.
Well, we have a subset of rules. They concern 64-bit. Well, I'll give you a little bit of history on that, or it will be, or you may miss the point here. The PVS Studio, it started when 2 people from Russia decided to compile their project with a 64-bit compiler from Microsoft specifically. And they found...
So it was working 32-bit code, and they said,
yeah,
let's just compile it and see what happens.
Okay, yeah, let's build it, let's migrate it to 64 bits. And they found a ton of issues. And so that's where the analyzer really started. They decided to write a program which will detect potential 64-bit issues. And we still have those old diagnostics as a subset of all other rules. And they are noisy, oh my goodness. Because they like to complain about pointers and classes, like a field. You have a field which is a pointer, be sure they will complain about it because they don't like it, because the class size will be different between architectures, stuff like that. So those 64-bit rules, we try to keep them out of sight.
No, wait. So what you're saying is, if you have a field that is a pointer, that gets called out. I mean, that doesn't sound like it's an issue to me, but they're saying it's a potential issue.
Yes.
Why? Because it means that your ABI would be different, right? Because if you expose this object, you were to pass this object in a function call or something like that, then obviously it would break between 64 and 32-bit.
Well, it won't break really, but the size will be different. So if you are counting on that your class has some specific size or alignment, it goes out of the window.
Sure, sure.
Also, there was a really huge problem when people they did for loops, and they did like a counter of unsigned int.
Okay.
Or something. And turns out that on 64-bit machines, you better use size T or something similar, because you may run out of the counter bitness for that. Especially if you, you might have a big array or data collection, and if you use indexes which worked fine in 32-bit, you suddenly may shoot yourself in the foot in 64 bits. It's not that huge deal really, those counters, but the fun starts when you come across legacy code when people store pointers in ints or longs or something.
Yeah.
That's a huge deal. I don't think right now many people run into this kind of problems, because everyone is using 64 bits, at least on computers, not in embedded systems. I'm not sure about them. But back then, it was early 2000s. It was a huge deal, and many projects suffered.
Well, storing
Or as I heard.
pointers in integers can be a problem for different reasons, of course, these days.
Yeah. Well, I'm kind of familiar with Windows API. I had to. And they do it all the time. Like you can put a pointer to the window as a long variable.
Yes.
And they cast pointers to integers a lot.
People writing OSs tend to be less interested in portability between architectures, because they know what their architecture is, right? So they make all sorts of assumptions that someone trying to write portable C++ code. When I write code, I never make an assumption about what size int is. And it's not just that I just don't know what an int is, and I just don't care. And if I ever think that I care because I'm going to do something with it, I use a static assert or something like that to make certain that my code makes sense if I'm making an assumption, I document it that way. But what people writing OSs, they know, well, we're writing this for this particular set of chips, and we know what kind of memory layout we're going to have, because they're writing an operating system, right? They're doing all those things. And so they do these really hacky tricks all the time. And people writing operating systems are not always, they don't always see eye to eye with people doing compilers, because they have literally a different worldview. I mean, the famous situation where the Linux programmers said, don't ever optimize out our null checks. We put a null check in on purpose. And the language guy is going, well, you've already. This is famous, and it's because the language people have a different way of looking at things than the operating system people do, because the language people follow the standard, whereas the operating system people know what the hardware actually is, and they know which assumptions they can make that are safe and which assumptions they can't make.
It's there's a funny thing about some embedded CPUs. I'm not sure. Maybe ARM also does this. Well, basically, you can write at address 0 there, because they have some system handler table or something at 0, and
Right.
so you can go there. You can reference a null pointer and write there.
Right,
It's
right.
fine.
Whereas a compiler author would say, someone knowing C++ says, wait a minute, the literal pointer of 0 isn't necessarily the actual numeric value of 0, right? The compiler is allowed to substitute that with whatever unique value is, cannot be returned from malloc or whatever the rule is. Peter in the chat room is saying long, it's capital, all caps LONG. In the Windows code I've seen is 4 bytes. Some people might assume lowercase LONG, in other words, the standard long would be typically 8B. And so that's what he's talking about is, it's an assumption that's made if you know what your operating system is and you make these kinds of assumptions.
I think the point there is don't assume that you can cast a lowercase long into an uppercase long.
Right. Yeah. I've actually, I looked at my own code once when I realized that I was writing code as making as few assumptions as possible that I always do. That's how I write C++. I don't make assumptions about Indianness. I don't make assumptions about length. I don't make assumptions about anything like that at all. And I was looking at this code and I realized, this is Mac code. It has to be Mac code. Look, I'm making Mac calls right here. And yet I'm still making all these guys, staying away from all these assumptions. And yet, as Apple has over time transitioned their code from 68,000 to PowerPC to Intel, these kinds of things paid off. Other people were, scrambling to fix all these things because they assumed, well, this is a 68,000 machine. It's running on a Mac. It's always going to be a 68,000 machine. Whereas I was like, I don't know what it's running on. All I know is this is C++ code, and so this is how it gets written. This kinds of things can pay off. But anyway, getting back to what you're saying is object or operating system people, they know these tricks, and from a performance point of view at the low level, this makes sense. Stick a pointer in here, treat it like an int, put it in a structure of ints, put it in an array, do whatever you need to do, and then know that you can turn around and put it in a pointer because that's the nature of the processor that you're running on. It's only language purists that insist that, well, the language rule didn't say you can make that. You can just arbitrarily put a pointer into an int and then expect it to work again. So getting back to the static analyzer is probably following the C language or C++ language standard and telling you this is the way the compiler is seeing your code. And so this is likely to be dangerous, even though well, on the code that I'm working on, it's not.
Well, actually, yes and no. It does follow the standard, and it knows what can be dangerous and what is safe, but it knows about different platforms also. So we support like PC, we support Windows and Windows, Linux, and Mac OS. And in Windows and in Linux, some types have different size. So we take this into account. And we also support some embedded compilers and ARM and a couple of other embedded CPUs. So there, some rules are different a little bit. So we take this into account. In general, yes, it's we just follow the language standard.
So Robert actually says in the chat room, he says that's why Linus only allows C, but I don't think that's I I don't think that's the situation, because the truth is the C compiler is allowed to make optimizations as well. There is a C standard. It's not as long, involved, and complicated as the C++ standard, but it also makes the same kinds of situations. I think Linus hates C++ for a completely different set of reasons.
Oh, yeah.
You know, I'm not sure if it's true or not, but I heard that C++, performance-wise, sometimes now is faster than C used to be, and C++ compilers can produce smaller binaries. So for embedded people,
Well, it's
Yeah.
certainly true, particularly if you're doing the kind of meta programming where you're doing type inspections and things like that, or type introspections and things like that. The potential is there, but again, I think that depends a lot on the specifics of exactly what you're working on. But getting back to static analysis. So here's the question I have for you. I told you what my company did. You know, we spent a lot of money. We bought this thing, ran it, generated a report that I actually did spend some time looking at, found some interesting things, thought that was cool, but then got back to doing production the way we always did, and it kind of got ignored. And so it was this huge boondoggle. How should a company use this? In other words, you know, can you make it part of a continuous build process? I think one of the things about this system, and I don't know that we used it very well because we didn't run it multiple times, but I think you could go in and you could create a file where you'd say, I've already investigated this. Don't tell me about this again. And actually tie it to the particular code that it's analyzing. And I assume if you rewrote the function, it has to still try to figure out that, oh, this was this thing, even though it's not a perfect match. How does that work?
there is a special file which stores what warnings you don't want to see. If you
Not based on the kind of warning, but based on where it was in the code.
yes, this specific warning,
Yes.
not the type, on this line.
Right.
And it stores hash of that line. So it stores data about the line itself, and not just the line number. So if the line goes up and down in your code, it will still suppress the warning.
Okay.
If you change this line, it will, if it finds anything there, it will again tell you that you're wrong.
Mm-hmm.
So, yeah, if you don't change the code and you said, okay, I don't want to know about this anymore, you won't hear about it again. Usually what we suggest is you just suppress either most of the warnings or at least low certainty level warnings.
Right.
And you look at the high level ones. If you find something interesting there, you fix it. If you find false positives, you just suppress them also.
Now,
and then
one of the things that I did was, as I was reading this, I would realize, oh, I can see why this looks suspicious. I actually rewrote some code to make the false positives go away. Is that useful use of time, or is that don't do that?
Don't do that. Just mark them as false positives, and let maybe the vendor know that, okay, so there's a piece of code like that.
If you're writing a library, especially a header-only library, like unit test framework, for example.
Oh, I think I catch what you're saying. Okay.
Yeah. Yeah, you have to make sure that it's not going to give false positives in other people's code. So I've often had to rewrite code into a way that I don't like at all, actually, just to get rid of false positives. And there are some cases where you can't, because one analyzer will give a false positive one way, and then you fix it so that goes away, and that then gives you a false positive with a different analyzer, and you can't control what other people are using. So it does get complicated.
The brilliant situation there is when you have this if statement where you say, if this, return here, else return here, and then you get one compiler that complains that there is no return for the function because you're returning within. So you add a return at the bottom. Say, okay, I don't care, fine, it'll never execute. I'll add the return. But of course, now another compiler is saying, hey, there's a return that is never executed.
Uh,
You can't
Oh,
make
yeah.
others happier.
I have a story about that.
Yeah.
I was doing some legacy code. It's like an ancient legacy from the old times. I was doing some refactoring that, and I look at it at the class and see, okay, there's a virtual function here. I know it's virtual. Let me put override next to it. Okay, it's good. Um, Microsoft compiler compiles it. GCC compiles it, and client goes, oh, it's inconsistency. You have override here, but you don't have it here, here, and here in the same
Oh,
class.
wow.
Those compilers, they also do that.
That's interesting. That's interesting. It's trying to be a style checker for you and say, hey, do we do overrides or do we not? Let's make up our mind. This is why we
Yeah,
can't have nice things, right?
like, come on, be consistent, dude. Stop
Yeah.
it.
Yeah. Okay. So if I'm installing the static analyzer, obviously the first step is it's only go the most certain bugs, because this is brand new code, and I'm going to go insane if I just say, oh, I want to catch all the bugs. No, because I'm going to get tons of false positives, and my eyes will bleed, and I will hate it, and I'll never use it again. So instead, start at the lowest possible level, or the highest certainty.
Highest certainty, yes.
Right. Okay.
And you can skip like lower levels entirely in most cases, especially if your project is kind of old and well tested. You know,
Sure.
If it's a project with history, you will probably get a lot of garbage because you won't get a lot of good stuff on it on its code when you check it first time. So yeah, you just suppress everything you don't like, and then you start running it regularly.
So would you recommend, is there a tool or a way to say, hey, this is, I'm working on a new function. I've added some new CPP files that were never there before. Can I say, be paranoid as heck about these, whereas everything else, some of it's not even mine. If you found if it was bleeding from ulcers, I still wouldn't care because it's not my code. Right? So can you somehow say this file is new and therefore suspect, whereas ignore these others? Can you do it on a file by file basis?
Well, it will be paranoid about any new file, of course, because it doesn't know anything about it. It doesn't
Because you won't have
any,
added anything to the false positive list.
Yeah.
Okay.
And if you don't care about some particular file, you just add it to exclusions and it's gone.
I see. Okay. All right. So I install new stuff, install it on a new project, and I get really paranoid, and I only do the highest certainty stuff, and I started to investigate bugs, and with any luck, I'm actually eliminating some problems. I'm looking at it, says this isn't going to happen often, otherwise we would already found it in testing, but it will still happen sometimes. It may be unusual, and maybe it caused me to take a look at the code and say, oh, this is just kind of buggy code. Maybe it needs to be rewritten, and maybe it can be faster. And maybe, you know what? It didn't need to be called at all. Let's just comment that out. Let's get rid of this. Okay, so we do this. All right. Now, so is there a way that I can incorporate this in my continuous build? How do I best leverage the fact that, every night we build the whole thing and I could generate a bunch of reports? How do I make use out of that?
Well, to integrate it, it's kind of easy because you just put it in your pipeline and make it run as a build step.
Right.
And for reports, well, first you can do it incremental. So if you are, you can make it check only something that changed in your code, actually, not
So in other
everything.
words, it remembers the previous report run and compares reports. So I'm
Yes,
only
it can do that.
reports that didn't exist yesterday. So this is a change I made today.
Okay, so good. So then it runs every day in your CI.
Okay.
if you get something new, so it doesn't bother you with stuff you've already fixed or suppressed or said otherwise that you're not
Right.
interested. If it finds something new, it can notify you, like for any new commit in your code base. It can notify you that, okay, this guy made a change that generated this warning in this file, this line.
Hmm.
And you can do it like that. You don't actually have to see it through logs if you put it in the pipeline, because it can notify you about new warnings and who's responsible for that piece of code. And then you can decide, okay, it's a bug, we're going to fix it, or you can just suppress it if it's false positive. But if you're going to suppress it, please let us know. Because if it's a false positive, we want to know, because we are kind of serious about false positives. We
Right.
don't like them.
So how do I let you know? I actually have to send you my code. My employer might not like that.
We will ask you for a minimal example where it can be reproduced.
I see.
Maybe not the entire file, but a tiny piece of code where a warning occurs. Maybe like a general pattern. If you can send us just a piece of your code, which is not like knee deep in macros or something. So if it's readable, that's my favorite game, is to find a line of code where a user had some false positive and make an example from it where I can reproduce it and then fix it. In most cases it works. Sometimes it doesn't, especially if you have something unobvious there. So usually, yes, maybe you can take a line from your code where you got a warning and maybe put some declarations, like mock declarations of classes involved in it or something like that.
Right.
It doesn't really actually have to compile successfully. It just needs to be parsable. Let's say.
Okay. So one of the things, and we were talking about this earlier, that the PVS Studio does is take a look at open source projects, run the static analyzer on that, publish the results, and what have you learned from that? I mean, you spend a lot of time looking at the kind of code people write in the real world, right? I mean, the analyzer is not worried about theoretical example code. It's worried about what real world people are writing. What have you learned about how, do you now think, I never want to see another programmer again, they're all complete and total idiots?
Now, I looked at my code I wrote like a few years ago, and I went like this, oh my God. Yeah, I became paranoid about what I write.
So talk to me about that. How has working on a static analyzer changed how you write code?
I guess I became more careful. I would say it like this. I try to copy paste less. I double check stuff.
So you literally do copy. You think, no, it's the same thing, but I'm just going to write it by hand anyway. I'm going to retype it, even though I could copy and paste it, but it's just less risky. You do that?
When I copy paste a line, I look at it at least twice after that.
Copy paste, look.
Yeah, and I don't copy paste like blocks of code usually. So it's I've had my share of stupid errors with that. What else? Recently we started doing refactoring, and we decided to put all pointer checking logic from our classes, from the calling code which uses classes and may come across pointers to some classes, we decided to put this into constructors and make sure that the class is constructed correctly and return references. I'm talking about the syntax tree we have, so it's a big deal because the syntax tree you can traverse it, and it typically gives you pointers to nodes because it stores. It's like a tree-like structure. Everyone knows how it looks. Now we return references in many cases from methods. Say, for example, if you have an expression like a plus b, a and b will be returned as references, and the class itself will check if it's constructed incorrectly from the parser, and it will explode if it's constructed incorrectly. So that's the approach we decided to take, because if I was paid $1 every time a null pointer reference occurred in my code or in someone else's code, I would be rich.
$1 billion mistake, isn't it?
Yeah, literally. Yeah, right. So what are you saying? You're using more of is that RAII? I mean, in other words, you're putting more logic in the constructor, guaranteeing that it will be carried out. And if it's not, then it fails. Fails spectacularly by throwing or whatever it does.
It makes your code safer.
Yeah.
Well, I think it's the best way I can put it. So
it's called correct by construction.
Yes. It makes your code safer. It makes you use more. By the way, it makes you use more standard library algorithms and containers instead of trying to do something by hand. So, because when you do something by hand, you have more potential to mistake. If you use something standard, you're probably fine, unless there's a bug there, but that's a different story, right?
Somehow, Marshall Clow and STL seem to write less bugs than I do. I don't know why that is, but
you sort of preempted a question I was going to make, actually, which is how much is using the type system more, using these correct by construction techniques, that sort of approach to coding in general, contracts as well. How well can static analyzers, including PVS Studio, follow that?
Contracts.
Well, that was just one example, but anything where you've checked something, say in a constructor, as the programmer now that anywhere else you can make assumptions about certain values, like it's not null, something like that. Can the static analyzer follow that logic through? So at the point of use, it knows this can never be null. We don't need to check it here.
It can usually, but not in like every conceivable case. But if you decide to dereference an internal pointer and it was checked previously somewhere in the constructor, for example, it usually knows that. That's not null. But that's. When you start talking about analyzing code between different functions, sometimes it becomes messy, because you have to carry around a lot of information, and some of that you may not have at some point. So it may be difficult, but in general, yes, it can track that. Okay, this thing is good. This thing is probably not.
So what do you mean by so what you're saying is you can know if I pass a value, I pass a pointer value, that I already checked in the previous code that it was not null. Is that what you're saying?
Yes.
You can be confident in analyzing the called function that there's no path where In other words, you may discover a path where if the pointer was null, that's a problem. But you know it's not a problem because it was checked before it was called.
Yes, yes.
But because this could be a situation of things being in another translation unit, you may not realize that that's happened.
You may not realize if it's in, well, if it's in different translation unit, you won't realize it.
Right. But that's still potentially something to look at, because it may be that the person writing the code assumed that the pointer is never null, but you would like to know that. The analyzer is telling you it better not be, and maybe you want to think about that. Maybe you just want to put it in a contract or something like that.
Yeah, if it's always not null, why is it a pointer, right? Why is it not a reference?
Good question. Good question.
That old chestnut.
Yeah.
Back to the $1 billion mistake.
Yeah. Robert is saying you need standard optional to counter null pointer. So what he's saying is that if you're using references, you may still have to deal with the situation where it could be null. And so I guess that's what he's saying. You could use optional, but if you're using optional, you know there's a explicit test to test it, right?
Well, if I use an optional, I can still write an arrow and do something with it. So it's not like a foolproof solution.
I think his point is if you go all the way and eliminate raw pointers from your code, always wrap them in something which is going to check for nullability. This thing can never be null. Well, then make it optional, and then you get back that nullability. Only in the places where you actually need it.
Yeah, makes sense.
So, is there a challenge to keeping up with the new standard as it comes out every 3 years, particularly with things like contracts specifically? This is something that's going to change the way you're going to analyze code because the code is guaranteeing certain, or at least implying certain things about the nature of the parameters passed in.
Yeah, when contracts didn't get into the new standard, we were like, why? Yeah, because we really wanted them, because the contracts, if your code had them, it would have put a lot of weight out of our shoulders. So we could just look at contracts and say, okay, so this function never returns null pointers, so it's safe, like always, or something like that. So yeah, contracts would have been great for us, actually. About the standards, it's kind of challenging, but it's not that challenging as like some people may imagine. We can do new features pretty quickly. At least we won't get scared of them.
Yeah.
Like recently we did concepts. Yeah, so now we understand them at the parser level.
Mm-hmm.
So the analyzer doesn't do anything about them at the moment, but it understands what's written there, because when we first looked at concepts, we started crashing. Yeah.
Well, if you can't parse it, yeah, that's going to happen. And I assume that nothing that happens on the library side is interesting at all.
On the library side, well, usually no.
Yeah.
Right. It's written really well, and like the STL, if we talk about STL. Other libraries, it's a different story, okay? So you can still find things there. STL is good. We don't have a lot of issues with it. Like,
so what I was going to ask you is there anyone on your team that goes to standards meetings? Do you have any representation at all? You have an interesting tool that depends on the standard, and you might have interesting observations that people in the standards committee would appreciate. What real code looks like.
We didn't we didn't manage to do that yet. But we go on conferences a lot, and there you can meet people from the committee,
Right.
and you can discuss stuff with them. It's kind of interesting what they say sometimes, because they are on the front lines, so they know stuff a lot better than we do.
Really?
And yeah.
I would assume that you would have insights that they wouldn't have, because you see a lot more real world code. You know, it's one of the things that I think Bjarne is quoted as saying, nobody knows what the typical programmer knows, or the typical C++ programmer knows. And there's a certain truth to that is, you know, if you happen to be in a particular industry, you overrepresent that industry in your mind. You might know, well, there are people who do different kinds of code than we do, but how important can they possibly be? Because they're not, I don't see them every day. And I think that's one of the things that's true. We don't really know. There's 5 million C++ programmers. How many of them, you know, what do they know? How do they think about C++? How many of them even know there's a standards committee? I think that's kind of interesting. Literally, a lot of them have no idea. Well, all they know is I have this compiler. If it works in the compiler, then that means it's part of the language. And if it doesn't, then it's not.
Undefined behavior, now it compiles fine on my machine, right?
That's right. That's right. Or it doesn't compile, in which case that's what the standard says, right? You want to know how many bytes there are in an int, you just type up size of int, and then it tells you how many bytes, and that's how many bytes there are. That's what an int is.
Oh my goodness, I just recalled another story. I've seen a forum post someday that a guy was complaining, oh, the new version of Clan is broken, it complains about my code, it generates something weird, it crashes all over the place, it, like an old version of GC doesn't do that. And then people got him into showing his code, and turned out that he had a signed integer overflow there.
He had what?
Signed integer overflow.
I see.
So,
and so
he had a UB.
Yeah. Right. Yeah, I remember, let's see, guess I shouldn't say the author name. There is a very popular C++, not so much. This was before, this was in the old days, before modern C++, but it was actually shipping out there. And it said, you know, that int was 16 bits and that long was 32. That's just what it said. And it was like, how can this get published? How can someone write a book and say this? And it was a book on C++. It wasn't like somebody was writing a book on how to write games or something like that. And they just said, no. It was a book on C++. And it said, you know, int is 16 bits, long is 32 bits. And that's just what those things mean. And it's like,
that's a good.
Talking of long, we are running a bit long.
Okay.
We should probably start wrapping up.
Winding up, yeah.
Sounds like we have plenty of material for a second show sometime.
Yeah. So, Yuri, we didn't mean to cut you off. Go ahead and finish your story.
What do you think? How many bits are there in a byte?
It depends.
Well, today's architecture, it's almost universally 8, but it used to be there were machines with 9-bit bytes and 10-bit bytes. It's
Yeah, I heard about all kinds of bitness per byte. So I don't believe any is the predefined sizes anymore.
Octet.
Yeah, it's often called the octet to get around that. It's like, no, this is what we mean. And I don't know that anybody's making any hardware that isn't 8-bit bytes in a long time, right? I mean, it took us a while to figure it out, but once we figured it out, well, it's partly because we're so English-centric, right? Programmers tended to be English speakers, and characters nicely fit in 8 bits, and well, characters nicely fit in 7 bits, but you know, what programmer is? People are trying to figure out the guy who I don't know. This is probably much too much aside, but I was just thinking about this the other day. That there's in the Bitcoin, which is, by the way, the Bitcoin protocol is written in C++. Right?
Mm-hmm.
And so you would think, well, maybe the guy that created this Bitcoin protocol, this anonymous person, maybe he was a programmer, except that the Bitcoin miner's fee every few years it halves, And so it's currently at like $12.50, and it's going to go, because it initially started at 50. And that means he's not a programmer, because no programmer would have started at 50. He would have started at 64, right?
Yeah.
So you know he's not a programmer. Whoever he is, he knew enough to write code, but he's not a programmer. He wouldn't have started the mining fee at 50. That's what we know.
Yes.
That's our
I bet he counts from 1.
That's probably, yeah. What is that? Counts from 1. All right. So we should probably, as Phil says, we should probably wind this up. It's been a lot of fun, and I love thinking about static analyzers and the problem of being able to analyze code and communicate what you're getting without those false positives. It's very interesting. This is the part in the show where we invite our guests to join us in wishing everyone safe coding, and particularly with your line of work, I know that you mean that very sincerely. So to everyone, we say, yeah. Was you going to say something?
Yes, I have to say it. Otherwise, I will be killed tomorrow. If anyone wants to try PVS Studio, you can use the link in the show
We're
notes.
put it in the show notes. Yeah. Okay.
Yes, and you get a trial for a month instead of a week.
Okay.
Okay.
Very
So
good.
I'm done with it now. I won't get killed. So
we should put that at the top of the show. All right. Yeah. So to everyone now, we say safe coding.
safe
Safe
coding.
coding.